welcome in. Sitting right there listening to this, you are doing exactly what you always do. You're looking for that next real breakthrough.
You're the learner. That's who you are.
Exactly. You're the kind of person who is constantly upgrading your understanding of the tech landscape, always searching for that crucial aha moment.
But you absolutely do not have the time to wade through, the endless sea of white papers and tech blogs.
Right. Who does? We know your time is a premium asset, so we have a highly targeted deep dive lined up for you today.
And it is a fascinating one.
It really is. We are dissecting this deeply fascinating piece that dropped on March 3rd, 2026. This was over at Geeky Gadgets.
By Jillian Horsey, right?
Yes, authored by Julian Horsey. And it explores this new framework, which is referred to as super nested Claude Code.
It is quite the moniker, isn't it? I mean,
Yeah.
super nested Claude Code.
It sounds like a movie.
It sounds like something pulled straight out of a cyberpunk novel.
Duh.
But the reality of what this system is executing right now, like today, in modern software development, it's incredibly grounded,
Right.
highly technical, and frankly, it is a massive leap forward.
So our mission for this deep dive is to completely demystify this architecture for you.
Write it all down.
We're going to examine exactly how combining advanced AI models, specifically Anthropic's Opus, with terminal multiplexers is creating this profound shortcut for parallel task execution.
We are talking about fundamentally re-architecting how a developer interacts with their local machine.
Okay, let's unpack this.
Let's do it.
Because nested Claude Code instances running inside Tmux terminals on macOS, that is a dense string of concepts right out of the gate.
It's a mouthful.
Yeah, but to really grasp why this is turning heads, we have to look at the actual mechanism of action here. Now, if you're listening to this, you probably already know what Tmux is, because it's using Tmux, which developers already use constantly to multiplex their terminal windows and keep sessions alive. Claude is essentially splitting your screen and driving multiple command lines natively.
All at once.
All at once. I like to think of it like a restaurant kitchen.
Okay, I like that.
You're the head chef, right? You decide the menu. That's your high-level objective.
Just setting the vision.
Exactly. And this system, it acts as your sous chef.
The central controller.
Right, the central controller. And then that sous chef dynamically assigns specific tasks like, chopping, boiling, baking to various line cooks.
And those line cooks are the individual Tmux terminals.
Spot on. It assigns them based on priority and complexity.
And the why behind all of this, like why it actually works, is because the system relies heavily on the Opus model.
Anthropic's Opus.
Right. Because your sous chef needs a really good brain to manage all those line cooks. Opus provides incredibly detailed, granular instructions for these tasks.
So it's not just running blind scripts.
Not at all. We aren't talking about basic automation here. We're talking about intelligent orchestration. The central controller is constantly evaluating the state of the project.
It divides the labor.
Yes, ensuring optimal resource utilization across the board.
Which is huge. But we have to bring this focus back to you, the listener. Like, why does this matter to you and your own tech stack?
Right. How does it change your day-to-day?
Exactly. It transitions your work from micromanaging individual tedious build processes to a goal-oriented workflow.
What's fascinating here is the psychological and productivity benefits of that shift.
Yeah, talk about that.
Well, think about how complex project development traditionally happens. You write a script, you execute it in the terminal, you read the error log.
You debug it.
You debug it, you run it again. Wow. You are the bottleneck. You are micromanaging the process.
Step by agonizing step.
Exactly. But a goal-oriented workflow means you define the objective. The system autonomously plans and executes the steps. By automating those repetitive tasks, developers are just freed up.
Freed up to actually think.
Yes, to focus entirely on innovation, on strategy, on high-level problem solving.
Okay, but letting an AI autonomously run terminal commands, that sounds like a recipe for a crashed machine.
It's a valid fear.
How do I know it isn't overwriting core system files or just running infinite loops while I'm getting a coffee? Is it just a terrifying black box?
That is the exact skepticism any senior engineer should have. But the article points out a crucial feature: transparency, real-time monitoring.
So it's not a black box?
Not at all. The system has a user-friendly interface, an overlay that sits right on top of the multiplexer.
Ah, okay.
And it has highly detailed activity logs. As a user, you always have a clear top-down view into the progress of the tasks and the overall system performance.
So I can see exactly what the line cooks are doing in the kitchen.
You can watch the terminal output stream in the logs. You remain in the loop, you maintain kill switch authority.
You just don't have to physically type the bash commands yourself.
Precisely.
Here's where it gets really interesting, though. Because Julian Horsey's piece in Geeky Gadgets doesn't just talk about this in theory.
Right, they have concrete examples.
Yeah, they dive into some incredible real-world demonstrations brought to light by the media outlet all about AI.
These demos are wild.
Let's look at the first one, procedural galaxy creation.
In 3JS.
Right. They use the system to build a procedural galaxy in 3JS, which, for those working in web rendering, you know is a massive headache to do manually.
It's incredibly complex from a dependency standpoint.
You're dealing with celestial objects, orbital mechanics, lighting all generated randomly but cohesively.
And the system used exactly 6 Tmux terminals for this.
6, working in parallel.
Imagine doing that manually. You'd be painfully building the WebGL rendering engine setup.
Then switching over to write the mathematical logic for random object generation.
Then separately designing the DOM elements for the UI.
Constant context switching.
It drains your sanity.
Yeah.
But with the Nested Claude Code system, the objective was just create a procedural galaxy in 3JS.
And the central controller spun up the 6 terminals. It broke down the parallel tasks beautifully.
Rendering in one.
Object generation in another.
UI development in a third.
And because the central controller is monitoring all of them, there are no merge conflicts. The result was a cohesive, seamless product generated with significantly reduced development time.
Infinitely faster than a single developer doing it linearly.
Which brings us to the second demo, the micro GPT training.
Also highlighted by All About AI in the source.
Yeah, break this one down for us.
This one is brilliant for anyone in machine learning. They used the system to visualize a micro GPT model's training process.
Which generates a ton of telemetry data.
So much data. Loss curves, token rates. You need a robust observability stack.
So how did the system divide the labor here?
Across 4 distinct terminals. Terminal 1 handled the back-end operations. The PyTorch model training loop.
Okay, the heavy lifting.
Right. Terminal 2 was tasked with real-time chart updates. So as Terminal 1 crunched the tensors, Terminal 2 visualized the loss curves.
Wow, in parallel.
In parallel.
Yeah.
Terminal 3 was concurrently creating the dashboard, the web app, to house those charts.
And Terminal 4.
Sample generation. Running inference on the checkpoints to show how the model's language capabilities were improving.
Epoch by epoch.
Exactly.
Doing all of that manually, tabbing between starting the training script, tailing the logs, updating the charting logic, refreshing the dashboard server.
It's information overload. Immediate bottlenecks.
But doing it this way resulted in a dynamic, real-time dashboard providing actionable insights without the developer breaking a sweat.
It proves the system can handle deeply complex, data-heavy AI workflows.
So what does this all mean? I mean, is this the absolute perfect tool we all need to install today?
Well, we have to do a reality check.
Yeah, pivot to the technical requirements and challenges here. Because it's not all magic.
There are definite hurdles. Julian Horsey is very clear about that in the text.
What's the biggest one?
Platform dependency. Right now, this system is strictly optimized for macOS.
Ah.
And it relies heavily on Tmux. So if you're on Windows or standard Linux, you're locked out of this specific ecosystem out of the box.
That's a huge chunk of developers.
It is. Plus, there's a very steep learning curve.
I can imagine. You're giving an AI access to your terminal.
Right. It requires a solid understanding of system configuration, setting up environment variables, routing API keys,
And security protocol.
correct adherence to security protocols. If you don't properly restrict the read-write permissions, it could cause severe system instability.
So less experienced users might definitely be deterred by that setup process.
It's a power user tool right now, for sure.
But there's a silver lining here.
Oh, absolutely.
Uh,
If we connect this to the bigger picture, the entire nested system is open source.
which changes everything.
It presents a massive opportunity for the future. It allows for rapid customization.
Meaning the community will fix that macOS limitation.
Exactly. We'll see cross-platform adaptation to other operating systems, Windows ports, Linux containers,
And probably abstraction layers to make the security setup easier.
lowering that steep learning curve so it becomes accessible to everyone.
So to summarize all of this, because we've covered a lot of ground today,
We have.
Nested Claude Code inside Tmux terminals represents a major leap in parallel task execution.
It turns complex, multi-step coding chores into autonomously managed, goal-oriented workflows.
And connecting that right back to you, the listener, Whether you are visualizing AI models or building interactive web apps, understanding these tools keeps you at the bleeding edge of efficiency.
You don't have to install it today, but you need to know it exists.
Because it's changing the rules.
And it leaves us with a really profound thought to mull over.
Let's hear it.
We've been talking about the system operating on a single Mac laptop, right?
Right, one machine, 6 terminals.
But if an AI can autonomously divide and conquer complex coding projects across parallel terminals on a single machine, what happens when this central controller mindset scales up?
Oh, wow.
Imagine a future where this system doesn't just manage terminals on your Mac, but it dynamically allocates tasks across a decentralized network of thousands of machines worldwide.
A global AI swarm managing microservices in real time.
Exactly. That is the staggering potential hiding inside this concept.
That is something to think about. Thank you so much for joining us on this deep dive. Keep questioning the tools you use, keep exploring, and we will catch you on the next one.